Hi everyone, in this video we are going to build ERC20 staking DApp. To build the application, we will use Scaffold ETH, which is an open source toolkit for building decentralized applications on Ethereum blockchain. Let's see the demo of the application. By the end of the video, you will have a website where you can get the ERC20 tokens, as we get 1000 here, stake them, withdraw them, and claim rewards. You can find the code for this app in the description. And here we are claiming, so let's start. You need to type npx create ETH at 0.1.5. Let's name the project ERC20 staking and choose Hardhead as a Solidity framework. Now let's wait until it finishes. Okay, everything is installed. Here are the commands we need to type. First, let's change the directory of the project and open VS Code or any other code editor you prefer. Next, let's open terminal and start Yarn chain, which starts a local Ethereum network for development. Then run yarn deploy to deploy smart contracts that we will review later. Finally, use yarn start to launch Frontend. And here's our website. Let's go back to VS Code. Packages, Hardhead, contracts, and here we already have yourcontract.sol, which we can delete. Before moving to staking, firstly we need to have our tokens that will stake. We need to create a file dapp_token.sol. And we define the license and Solidity version. The SPDX identifier MIT specifies that contract is open source and can be freely used. Then we set the Solidity version to 0.8.19. Next, we import two essential OpenZPLN contracts. ERC20.sol provides standard ERC20 token functionality, and ownable.sol ensures that only the contract owner can execute certain functions. These imports allow us to build a secure and efficient token without reinventing the wheel. Now let's define our DApp token contract. It inherits from both ERC20 and ownable. In the constructor, we set the token name as DApp token and symbol will be DApp. Also, we will call ownable message.sender, which makes the deployer of the contract the owner. This means whoever deploys the contract will have special privileges like minting tokens. Now let's create a min function, which has two parameters, the address which will receive the tokens and the amount. This function can be called only by owner. Account. Next we will create a claim function, which will be useful for anyone who wants to test our app, and that's why we leave it public. When a user calls claim, it means 1000 DApp tokens directly to their address. But here is the takeaway. This function does not have any restrictions, meaning any user can call it multiple times to get unlimited tokens. For this app, we will leave it like this. Now let's start with a staking contract. For the staking contract, let's create another file in contracts folder, which will be called ERC20 staking.sol. The license is MIT and Solidity version is the same. Next, we import ERC20.sol, which allows our contracts to interact with any ERC20 token that users will stake. By using an interface, we avoid rewriting standard ERC20 logic. The ERC20 staking contract is structured to handle staking and rewards efficiently. We will define staking token and reward rate. Also, we will use three important Solidity features: structs. We define a stake struct that keep track of amount the tokens a user has staked, start time when a user started staking, and reward depth. Rewards that have been earned but not yet claimed. Mappings. We use a mapping stakes to store each user's staking information, allowing efficient access to their staking status. And events. We're going to have three events. The first one is staked. When the user staked, the second one will be withdrawn, when the user withdraws the stakes, and reward claimed, which will be emitted when a user claims rewards. In the constructor, we define staking token, the ERC20 tokens users will stake, and reward rate, which determines how many rewards tokens users earn per second. Let's start with the main functions. And the first one is stake function, which has one parameter, amount. Firstly, let's ensure that the user is staking more than 0 tokens. Then the contract calls transfer from on the ERC20 token to move tokens from the user's wallet to the staking contract. Let's retrieve the user's current stake data from the stakes mapping. If the user has an existing stake, let's calculate their pending rewards and with calculate reward, which we will define later, and add it to reward depth. Then we need to increase by amount and update start time. Finally, we need to emit staked event. The calculate reward function determines how much a user has earned over time. There is one parameter, user, so let's get the value for the how much user staked. Multiplied by reward rate, multiplied by the time elapsed since the last update, and divided by 10 power of 18 to maintain the precision. The next is withdraw function, which allows users to get back their staked tokens. In this function, we also have one parameter, amount, that the user requested. Firstly, we need to check that the user has enough staked tokens. Then we need calculated pending rewards and add to reward debt. And finally, reduce the staked amount and send the requested amount to user. And also, of course, emit the event withdrawal. The next function is claim reward function, which lets users collect their accumulated rewards. Firstly, let's get message sender's information. And calculate the total rewards. Then we need to check that the rewards are higher than the 0. We will update the reward depth to 0 and update start time. So lastly, we need to send the accumulated rewards and emit the event reward claimed. The last function is claimable rewards, which will be helpful to see the total rewards for the user. Now, let's move on to the deployment script. Let's change from your contract to DApp token. And this contract does not have any arguments. Then we will define reward rate. And we also need to deploy a staking contract. Where arguments are the address of DApp token and reward rate. Okay, let's remove this. Right now, staking contract does not have any DApp tokens to give them as rewards. So let's mint to the staking contract 1 million DApp tokens. And that's it. Finally, we need to deploy the contract with yarn deploy command, and we can already interact with smart contracts in the debugger page. Let's go back to our website. Here we have a debug contracts page where we can see our two contracts. First of all, let's check how many tokens do we have right now. We have 0. So first of all, we need to get some ETH for the gas by clicking this faucet button. And now we have 1 ETH. So then we need to claim so we can get some of the DApp tokens, and now we have 1000 DApp tokens. Let's check ERC20 staking contract. Here we can also check our claimable rewards. Everything is 0. Before staking, we need to approve to allow the contract to spend our tokens. So let's indicate the smart contract and say that it can use 1 token. So let's take 1 token right now. So we staked 1 token, and let's see how many tokens do we have. We have 999. And here it still says 0 because there are no blocks processing in our local blockchain. And we can see that there is 0.17 tokens that we can get. Let's claim them and check how many tokens do we have right now, and which is already became 0.28. So we tested our contracts and it seems everything is working fine. Now let's move on to the front-end part. So let's close all the files and go to the page.tsx. Here we can remove this. We can remove this and rename this part to ERC20 staking DApp. Also we can remove this. And we don't need this as well. Okay, here are our results. So let's create a components folder. And here we need to create 2 files. The first one is stat card, which has an interface with a title, value, and action, which is another React element. Okay, let's create a component. So the first it's div with a stat, which we are taking and using from the Daisy UI. And also next to the title, let's also have a button action, which will be a button. And also let's create another component, action button.tsx. Also let's define the interface. And let's create a button. Here we'll have a lot of properties like on click, is loading, loading test, default text, and disabled. Here let's define the button, and the only thing, let's add to the class name button XS to make it very small, and button secondary. And also there is no such thing as btn loading, so let's change it to loading. Also we will create another component which will use the start card and action button components. Staking dashboard, and which will return like a basic text for now, and export it, and let's import it here. So let's see how it looks. Okay, we can see staking dashboard. Let's add some paragraph. Here let's create a div which will use components from the Daisy UI. Now let's import here start card components that we created before. For the first one, the title will be token balance, to see how much tokens the user has in the wallet. Firstly, we will just give a random data. For the second card, it will be staked amount, to see how many tokens the user staked, and for the third one is to see how many rewards earned so far. And here's our dashboard. Now let's change the mock data with the real data. Firstly, we will use user account from WAGMI to get the connected address. The second one is use scaffold lead contract, which will helpful to get the token balance for the user. The contract name will be DApp token. And the function name is balance of. And argument will provide the connected address. Now let's here display the token balance. If there is such one, then we also need to convert it from the big integer to the string, and if there is no token balance, we will just show 0. Also, let's prepare some functions for the claim button, to be exactly airdrop claim button. So firstly we need initialize write contract async from use scaffold write contract, and the contract name is DApp token. And let's create a function handle airdrop. So the user can easily claim some tokens and test our app. For this one, let's set the airdrop is claiming to true and initialize the function write token contract async, and the function name is claim. Here we also need to, when the block confirmed, we also need to set that airdrop is claimed, and also if there is an error, we will send a notification. Which will be imported from scaffold ETH. So here let's add the action button. we import action button that we created before. On click it will be handle airdrop, is loading is airdrop claiming, and loading text is claiming, and default text is airdrop. So we will also disable it if the user is claiming the tokens. Let's check the function. Firstly, we need to get some ETH for the gas, and we can see the airdrop button. Let's click it, and we get 1000 tokens. Now let's get the staked amount and the rewards amount. So for the staked amount it's the same as for the token balance, but in this case the contract name will be ERC20 staking. The function name is stakes, and the argument is the connected address. Some little typo. And also let's get the reward info. Token rewards, it will be the same lead contract hook, and the contract name is ERC20 staking, and the function name is claimable rewards, and the arguments is a connected address. So here also let's use scaffold light contract, but in this case the contract name is ERC20 staking. Let's have another state for the claiming rewards, which will be is claiming and set is claiming. Also let's create a function to claim the rewards. It will be very similar to the handle airdrop. The only difference that the variable names is different, and also function name is, it will be claim reward. So now let's, for the staked amount, use the staking info and 0, which is a staked information, which is the amount of staked. And if we don't have it, we will just pass 0. And the same thing for the rewards. Also let's pass the action, which will be similar to the first one, but it will be regarding claim the rewards. And here we have a button, but we can't test it yet. So now let's create a token staking form.tsx. Also here we'll use account hook. Use account hook from WAGMI, and now let's define some function, some variables, like stake amount, withdrawal amount, is approving, is staking, and is withdrawing. So let's firstly use scaffold contract for the staking contract, where the parameters contract name is ERC20 staking, and this hook is imported from hook scaffold ETH. So firstly we would like to check if the tokens that belongs to users are allowed for the staking contract, which is necessary for the ERC20 tokens. Now let's prepare the light token contract async from the use scaffold light contract hook. Contract name is DApp token. And let's do the same for the ERC20 staking. Firstly, we need to handle a proof where Copilot has suggested, but the only thing we need to get the value from the stake amount, which user indicated, and pass it to the function. And in case error, just cancel error. And also notify the user. The second one is handle stake, which is similar to handle approve, but the function name is stake, and related variables are called. And also handle withdraw, which is very similar. Actually, it would be nice to create some kind of generic functions for them. Here is the same. Function name will be withdraw. And actually, I forgot, after staking, we need to set stake amount to empty. Here we'll do the same. So in case the error is the same as in the previous function. And now let's move to the UI, where you understand more how these functions are useful. Firstly, let's create a label. Stake amount. And here we will use integer input component. The value will pass stake amount, on change set stake amount, and placeholder will be amount to stake. Let's import it from component scaffold ETH. And also we will disable multiply by because we are already doing it in a function. And here we will have two different buttons depending on the allowed stake tokens. If the tokens are not approved yet to the smart contract, then we will display approve button, but if they are already allowed, then we will display stake button. Here we firstly will check if the allowed tokens are less than the amount that the user indicated in the input. Here we'll have a button. In case if it's approving, it will be loading. And on click, it will be handle approve. We also will disable it in case it's approving. Actually, here it would be nice to create a separate component for this, because they are very similar. But here, instead of approving, we will use is staking and handle stake and is staking. And the same thing for the text. Okay, now let's also import token staking form. And here's our first input. So let's approve one token, and after the transaction was confirmed, we can stake it. And now we can see that the UI is also changed. We have one staked amount. Now we need withdraw operation. So let's create a label for it. It actually would be possible to create a separate component for this, so it will be easier instead of repeating, but it is how it is. In the future videos I will try to make it much better. So integer input, withdraw amount, and the same idea as before. And button, it's exactly the same, so it would be nice to have a separate component for it. Here the rewards are not increasing because on our local blockchains there are no transactions are happening. So after we approved and staked 100, we can see the rewards are increased. Let's also test the withdrawal, which worked as well, and claim the rewards. And everything works. Now let's deploy the contracts to Sepolia testnet. Firstly, we need to generate an account. Please keep it safe. You can type your password, and here's our account. Firstly, we need to send some ETH Sepolia there. I will add some links in the description where you can get them. So I'm sending. And we can check it with Yarn account. So we can see that in Sepolia I have a balance 0.01 ETH. And let's deploy with the following command: yarn deploy --network Sepolia. So it's deploying DApp token and ERC20 staking contract. Now let's verify the contract so anyone can see the source code on the scanners. Now we need to deploy the frontend. So let's go to the scaffold config.ts and change from the chains.hardhat to Sepolia. Finally, let's deploy the frontend. If you are deploying for the first time with Vercel, then you need to log in first with yarn Vercel login, and then enter the command yarn Vercel, where you need to indicate the name of the project and select some option. In the end, you will get the website like this, where you can get the DApp token, stake them, but before we need to approve the tokens to the smart contract. Let's withdraw 10 tokens and claim the rewards. Thank you for your time. I will be glad for any feedback. Thank you.